Hey everybody, welcome to another video. This one actually will cover two sections in one video, section 5.2 and 5.3, perpendicular bisectors and angle bisectors. They may sound like they'll be easy to confuse because they both have the word bisector in them, but we will clear that up. We will make sure that it's easy to tell what is what. So, first thing we're going to talk about is perpendicular bisectors. And what a perpendicular bisector it is a line that is perpendicular to a segment at its midpoint. So, let's say we have segment AB here. Well, what that means is if we go to the midpoint of AB, looks like it's right around here, and we make a line that goes at a 90-degree angle to AB, and again through its midpoint. This line here, let's call it L, is a perpendicular bisector to segment AB. Now, the perpendicular bisector has a really special feature. And what that feature is that a point is equidistant from these two figures. So a point is equidistant from A and B if that point is on the perpendicular bisector. So, for example, if we put a point here, it's on the perpendicular bisector to AB. This distance here and this distance here are going to be the same length every single time. So, we say also that a point is equidistant from two figures if the point is the shortest distance from each figure. But when you're on your perpendicular bisector, that's always going to happen. So, part of our perpendicular bisector theorem is that if a point is on a perpendicular bisector of a segment, then it is equidistant from each endpoint of the segment. Another way to say it is, if CP, so let's put some points on the segment here. If CP is the perpendicular bisector of AB, then any point on CP is equidistant from A and B. So, I don't know if I can hammer that point home any harder. Basically, being on the perpendicular bisector means that you're the same length from each of the endpoints of the segment that you're the perpendicular bisector of. So, as an example of how we would use that, we can see from this drawing that SU is a perpendicular bisector to segment RT, because we can see a 90-degree angle here, and also that this segment is congruent to this one. That means that SU is a perpendicular bisector to RT. Now, using our theorem, if that's the case, that means that any point along SU is going to be equidistant from RT. That includes point S. So what that means is that if we start at S and we go down this side, that's going to be the same length as going down this side. This is congruent to this. So if we need to find the length of RS at that point, all we need to do is set these equal to each other and solve for x. Once we have x, plug it in to find out what RS is. So 9x plus 15 equals 5x plus 31 minus 5x. Those cancel out. Minus 5x. That reduces to 4x plus 15 equals 31. Minus 15 minus 15. 4x equals 16. Divide by 4, divide by 4. 16 divided by 4 is 4. So x equals 4. We need to find the length of RS, so we plug 4 in, and we get 9 times 4 plus 15 gives us 36 plus 15, which is 51. And that's the length of RS. So we use the idea of perpendicular bisectors and the fact that we know that any point on it is equidistant to the endpoints of our segment to help us figure that one out. All right, moving on to 5.3's info, angle bisectors. So, what is an angle bisector? Well, it's a ray that divides an angle into two congruent angles. So, let's say we have this angle here. Well, what that means is we are going to split it directly in half, making two angles that are the same size. Notice that that's a ray. And what we have there then is an angle bisector. So, in order for us to understand what the angle bisector theorem is, we need to talk a little bit about what distance from a point means. Because when we talk about distance from a point, we could technically refer to a bunch of things. Like if we look at point P here on the next line, we could say that we want to measure the distance from this point to this line down here as being this segment here. But wouldn't it just be as easy for us to say that it's this length here? It would. And the problem is those lengths are different. So we establish an idea of what distance means. And what we establish it to be is that the distance from a point to a line is the length of the perpendicular line technically perpendicular line segment from the point to the line. So basically, if we want to find the distance from P to the line, we just need to make sure that we make P go straight down to make a 90-degree angle with the line. So that whatever that length is, that would be the distance. Now that's important because when we would talk about angle bisector theorem, what we're going to say is, if a point is on the bisector of an angle, then it is equidistant to each side of the original angle. So let's say that this segment here is the angle bisector. What that means is if I choose a point like right here, then if I make the perpendicular line down to this angle, and I make the perpendicular line up to this angle, then they're going to be the same length. This will be congruent to this. And it should work anywhere on the shape. Now, I didn't draw it very well, so you can see that up here it doesn't quite work as well. But if you carefully measure the angle bisector using a protractor, you're going to get better results. If this were the true angle bisector, then this would be the same length as this. So, using that in an example, find the value of x. Well, here's what's going on here. First of all, We know that these are right angles, which means that this line segment here and this line segment here are indeed the distances from this point over to these two sides, and we're told that they're the same length. Well, remember, those being the same length means that we have angle bisectors. Also, if we had been told that these angles were the same size, which we now know they are because of angle bisectors, then we could also figure out what these lengths were, because they would have to be congruent. But anyway, on this problem, we're asked to figure out the value of x. So we know that this angle, which is 6x, is the same size as this angle here, which is 2x plus 16. We just need to use algebra here at this point. Minus 2x, 4x equals 16. Divide both sides by 4 gives us that x equals 4. The directions for this one just wanted x, so actually for this problem, we're done at that point. And now that you've watched this video, a little longer than our normal ones, but it covered 2 sections, you are now ready to try both sections 5.2 and 5.3. So that's it for this one. At this point, you should be ready to try out the practice quiz homework assignment. It's a worksheet found in the box. And also, if you want to explore these ideas a little more clearly and a little further, I do have activities made on Geometer Sketchpad that cover this material in a little more depth, and it'll actually allow you to see it if you're more of a visual learner as well. You can sort of see it happening. There are worksheets made up in the box to go along with the Geo Sketchpad activity. I would recommend working on it with a partner. So there aren't so many copies in there, but I would recommend trying it out. Thanks for watching. See ya on the next video.